Hi, this question is from the topic structure analysis and this comes under the subtopic of static indeterminacy. The level of difficulty involved in this problem is medium and the approximate time it takes to solve this problem is 75 seconds. Okay, we'll start the problem. In this problem, what is asked is we are asked to find out what is the vertical reaction at this support Q. Okay, and what is expected from the student is they need to know what is meant by static determinacy and indeterminacy, and then one need to know what happens when there is an internal hinge. We will see that and we'll move on. Fine. So first we will start with static indeterminacy. A structure is called statically determinate if the unknown forces in the problem can be solved with just the equations of equilibrium. Okay, and the equations of equilibrium are summation of vertical forces equal to 0, summation of horizontal forces equal to 0, and then summation of moments equal to 0. Why this is demanded is when we have a structure under the action of forces, it can deform to permissible limits, but it should not move away, right? So let's say when an object moves away is when there is a resultant force acting in an object. What happens? It will accelerate because force is equal to mass into acceleration, right? So we don't want any non-zero resultant forces or non-zero resultant moments in our structure, because otherwise the structure will move or rotate if there is any non-zero resultant force or moment. Fine. So this is a demand from this basis, and these three equations we can make use of in order to solve for unknown forces. Fine. Let's see what are some statically determinate structures. There are three statically determinate structures. One is not shown here. The others are simply supported beam, cantilevered beam. The one which is not shown here is overhanging beam. And if one understands these two, one can understand what is an overhanging beam and then why it is called statically determinate. Fine. Before going into the concept of simply support cantilevered beam, one needs to understand that if a particular displacement is arrested in the given structure, there will be development of reaction. Okay, I repeat, if a displacement is arrested in a particular direction in the structure, there will be development of a reaction. Fine. Now let's see this given beam. This given beam is acted upon by a vertical load at this point, and we have two supports at both ends. This support is called a hinged support, and hinged support doesn't permit horizontal and vertical displacement. Fine. So just I have said, if a displacement is restrained, there will be reaction, right? And we have said hinged support doesn't allow for horizontal vertical displacement. So along horizontal direction there will be a horizontal reactive force, and along vertical direction there will be a vertical reactive force. So horizontal reaction is called H here, and vertical reaction is represented by V1 here. Fine. And coming to the other end, we have a support called roller support here. What happens at a roller support is free to move in the horizontal direction. So it can move like this, but this is not allowed to move in the vertical direction. So it can't move in this direction. Fine. So as the displacement is arrested in the vertical direction, we see a reaction in the vertical direction, and it is represented by V2 here. So as such, we are seeing the number of unknowns are 3 here, H, V1 and V2. And what are the equations available? The equations available are equilibrium equation sigma H equal to 0, sigma V equal to 0 and sigma M equal to 0. So we have three unknowns and we have three equilibrium equations. So we can solve for the unknowns H, V1 and V2, right? Now we are moving on to the next determinate beam, which is a cantilever beam. It has a free end and it has a fixed end. Fine. At the point of fixity, the horizontal displacement and vertical displacement and the rotations are all arrested. Fine. So we are seeing a horizontal reaction, a vertical reaction, and a reactive moment here. Fine. Because we told if some displacement is arrested, there will be a reaction, right? That's why we are seeing these three reactive forces here, right? So the unknowns are three numbers here, and the equations of equilibrium are also three numbers. Fine. So we can solve for H, V, and M in this case. As we are able to solve for the unknowns with just the help of equilibrium equation, these are called statically determinate structures. And overhanging beam is also statically determinate because we can solve for the unknowns with the help of these three equilibrium equations alone. Fine. Next, the actual problem is this, which contains an internal hinge here. Suppose if there is no internal hinge, let's see what happens, right? So this is the modified problem for illustration, which doesn't contain an internal hinge at this location. Okay. So now we have fixed support as we have seen in the previous slide, which basically contains three unknown reactions, right? That's what is shown here. At fixed end, the number of unknowns are 3. And this is the roller end. The previous slide we have said that it carries one unknown vertical reaction. So at the right end we have one unknown reaction. So totally 3 plus 1, 4 unknowns are there, and the number of equilibrium equations we have are only 3. So the number of static indeterminacy we call in this case is 1, because we can't solve one unknown in this problem just with the help of equilibrium equations alone, because we have 3 equilibrium equations but the number of unknowns are 4, and this is called statically indeterminate by degree 1. Okay, so this is the case if there is no internal hinge, but if there is an internal hinge, we'll see what happens. Basically the presence of internal hinge will provide us one more extra equation. So in that case, this 4 minus 3 plus that one extra equation, 4 minus 4 will go to 0. We will see further, right? I'm just giving a gist. So this is what we need to know about internal hinge. Internal hinges are often used to join flexural members at points other than supports, and they do not transfer bending moment from one part to the other part. They transfer only axial and shear forces. Fine. This is important, and the most important point is given here. The bending moment at the location of internal hinge is always 0. Okay, this is the most important point one needs to bear in the mind. Okay, having said that, we will solve the problem now. How we are going to solve the problem is, we need to draw the free body diagram of different parts. Okay, and we need to make use of the fact that is highlighted in the red marker here. That is, the bending moment the internal hinge is 0. Yeah, now the problem is this. We are drawing the free body diagram here. The left part is, what we are doing here is we are making a cut at this location R, and we are drawing this PR separately here and RQ separately here, right? When we make a cut, we need to expose all the internal forces that are available. In a beam, the internal forces are basically axial force, shear force, and the bending moment. Okay, so at the cut point R, we are seeing a set of axial forces which are equal and opposite, because only then there will be equilibrium here. Similarly, we are seeing a pair of forces VR, which are the shear forces that are equal and opposite in direction here to maintain equilibrium, but we are not seeing any bending moment here. Why? Because we told the bending moment at the location of internal hinge is 0. Okay, that's why we are not seeing any bending moment here. Fine. And then at this point we are seeing 3 reactions, because this is a fixed support, and at this point Q we are seeing one vertical reaction here, VQ, because this is a roller support. Fine. Now we have 2 portions. In some problems we will have to make use of these both portions, but in the given problem what we are asked for is to find out VQ. Okay, so we don't need left portion. We are going to make use of only the right hand free body diagram. Fine. Yeah. Alright. Now in the given problem, the distance between this point of internal hinge and the point Q is L by 4, that is indicated here, and the vertical reaction at this point is given by VQ, the forces, internal forces we exposed are one axial force NR and a shear force VR. Fine. Now we know that if we take moment, summation of moment about any hinge, it should go 0, because only then equilibrium will be satisfied, because we have said basically summation of horizontal forces, summation of vertical forces, summation of moments should be 0 if you take any point in the 2D planar system for equilibrium to be maintained. Fine. So coming back to this slide, summation of moments about this point R is set as 0. Fine. Now what are the forces available here? If we take moment about this point, we have only VQ. So VQ into L by 4 will produce an anticlockwise moment, and we don't have any other forces or moments here, so that directly is equal to 0. From this we are saying VQ equal to 0. So the answer is A. The support reaction at VQ is, the point Q is 0. Thank you.